Okay. So this is the review for study guide for test 3. We begin with the first question. Find the difference between the sample means, find the standardized test statistic, decide whether the p-value is less than or greater than alpha, decide whether you should reject or fail to reject the null hypotheses, and these are the samples. He says the claim is mu1 is less than mu2, alpha is 0.01, x1 bar is 1235, and 1 is 35, x2 bar is given, and 2 is given. Population standard deviation, sigma 1 and sigma 2 are given. All you need to tell me, guys, what test do you use here? Remember, sigma 1 and sigma 2 are given here. So what is the test going to be?
Z-test.
What is it?
Is it Z?
Z-test. Yes, that is correct. The two-sample Z-test. If you understand, just the test and know exactly what test you are going to be using, I don't think there's even a chance that you guys can make a mistake here. But you need to know that because he gives you sigma 1 and he gives you sigma 2, it's labeled as Z. This is a Z-test, guys. Now, it's not one sample Z-test because he gives you two samples, so it's going to be, guys, two sample Z-test. Again, for students who are wondering why we're doing two sample Z-test, because he gives me sigma, he didn't give me S. And when he gives you sigma, we're stuck with a Z distribution. So we will go to the calculator, guys. Watch. Let me open up the calculator. And since we agreed it's a Z-test, you just go to stat, tests, and here you go, guys. It's number 3. Enter. A summary. See, he's asking for sigma 1 and sigma 2. The calculator is asking for. So let me just move this away. Sigma 1 is 65. Sigma 2 is 105. And x1 bar is 1235. N1, guys, as you can see, it's 35. N1, x2 bar is 1195. N2 is 55. And then, okay, now the claim, the alternative hypothesis. Well, he gave it to you. He says mu1 is less than mu2. So just select mu1 is less than mu2. Enter. You must select and press enter. And now let's do calculate. And here you go. And let's answer the questions. The difference between the two sample means, so he wants the difference between x1 bar and x2 bar. That's not related to the hypothesis test here that we did on the calculator. So 1235 minus 1195. What is 1235 minus 1195? You don't put the answer like that, but I'm just showing you how to do the math here. So it will be 40. Okay, the next one, let me bring back the calculator screen. He wants Z, which is 2.23. He says round it to 2 decimal places, so it will be 2.23. Don't put Z equals, already that would be marked wrong. Just put the value. Is the p-value less than alpha or more than alpha? Look at the p-value, guys. It's a 0.98, so it's more than alpha. So is the p-value less than alpha? We say no, it's not. Should you reject or fail to reject the null hypothesis? Because the p-value is not less than alpha, it's more than alpha, we fail to reject the null hypothesis. So at the 1% level of significance, there is not enough evidence to support the claim. Every time you fail to reject HO, you say there is not enough evidence to support the claim, and that answers the question. Any questions here? Oh, the chi-square test is when you have like more than 2%, the distribution, you know, just of 3 or 4 or 5 proportion percents. Here, there are no proportions. So, and here he's asking you, he's giving you mu1 and mu2. Once he gives you mu1 and mu2, you know it has nothing to do with the chi-square test. It has to be either a 2-sample z-test or a 2-sample t-test. So that is the first question. Let's go to the next one. Okay. Test the claim about the difference between the two population mean, mu1 and mu2 at the level of significance. Assume the samples are random and independent, the population are normally distributed. Okay, the claim is mu1 equals mu2. Population statistics, look what he gives you guys. He gives you sigma 1 and sigma 2. So you should agree with me again that this is going to be a 2-sample z-test. I don't know why the screen is disappearing on me. Now it's working. So it will be 2-sample z-test. And if you ask me why again, look guys, this is your chance to refresh your knowledge. Sigma 1 and sigma 2 are given, then it must be a z. Okay? So determine the alternative hypothesis, where if the null hypothesis is equal, the alternative hypothesis, guys, is going to be not equal. Determine the standardized test statistic. Well, I have to do the math now. So clear, and let's do the math together. So stat, again, I'm just going to go slow with this one. Number 3. Okay, sigma 1, guys, is 3 point. Let me just, is it 3.3? Let me just clear this. I don't see it well. Okay, 3.3. 3.3, guys, watch. Sigma 2 is 1.6. X1 bar is 16. And 1 is 30. I'll just copy what I see. X2 bar is 14. So what I'm trying to tell you guys, in other words, if you pick up a test and it says S1 and S2, don't use it because you don't have S1 and S2. So you must have selected the wrong test. It has sigma 1, sigma 2. And look, this one has sigma 1 and sigma 2 there. N2 is 26. And then mu1 is different from mu2. So make sure to select enter and hit calculate. And that's all I need, guys. Okay, Z is 2.94. So you just put 2.94 right here. A p-value is 0. How many decimals? It says 3 decimal places, it will be 0.003. What is the proper decision? That's less than alpha. 0.003 is less than 0.0. So reject HO. And there is, can students select the final answer for me? So let me just get rid of the calculator. So we rejected HO. Which one do you select, A, B, C, or D? Well, definitely not A and D, because A and D has failed to reject HO. So which one is it going to be? Let's see what we have in the chat. So I got an answer. C, let's see. There is enough, excellent. There is enough evidence to reject the claim. And that is correct, guys, because you reject HO and the claim is in HO, there is enough evidence to reject the claim. I agree. Very good. See, it's not hard at all. It's the same. We're repeating exactly what we learned today, you know, as far as interpretation. Okay, let's go to another one. All right, here. You see, guys, here what he gives you right away. Let me just, I know some of you, the more tests you get, the more confused you get about it. But look what he gives you here. He gives you S. If he gives you S, guys, you don't use a Z test. It's a T test. So let me highlight this. This is S1, and this is S2. So it must be a T. And if I were a student, I want to figure this out. I know the teacher says if you get S, it's a T. But since I have two of them, so I know the teacher said just put two sample next to it. There you go. It's two sample T test. Research conducted to determine whether magnets are effective in treating back pain. The results are shown in the table for the treatment with magnets group and the sham placebo group. The results are a measure of reduction in back pain. Assume that the two samples are independent, simple random samples selected from normally distributed population. And do not assume that population standard deviations are equal. This last statement, guys, should give you a hint for pooled. When he says populated, don't assume that they are equal, so pooled is no. And when you know there is a pooled in the question, it must be a two sample T test. It can't be any other tests. Okay, so let me, annotation is not working. So pooled is no here. All right. Use a 0.05 significance level to test the claim that those treated with magnets have a greater mean reduction in pain than those giving a sham treatment. Okay, guys, so can you help me out selecting the null and the alternative hypothesis? Okay, to repeat how you know if it is pooled or no. If he says, assume population variances or population standard deviation are equal, then pooled is yes. But here, look what he starts with. Do not assume they are equal. That means they're not equal. Then pooled is no. Does that make sense? Great. Okay, guys, let's go to the calculator. And before we go to the calculator, let's determine which one is the null and the alternative hypothesis. Okay, Safa says it's B. Well, it says use 0.0 to test the claim that ones who treat it with magnet have a greater mean reduction than those who treat it with nothing. So you change to a D. And I agree. Probably you're wondering why there is not a greater than or equal to. Yeah, there should have been a greater or equal to in D. That's the only one that has a greater than. You have to use it. I got this question from a different book. And as I told you, there are some other books put just the equal sign. But for the sake of the test, guys, I'll make sure that this will show a greater than or equal to. So it must be D. Okay, let's run the test. There's my calculator. You should frame the calculator and put it on your wall because it's very important by the end of the semester when you pass this class, because without it, it's very hard to do the work in this class, extremely hard. It's time consuming to do the calculation by hand. So we're gonna go to two sample t-test. Sorry, it's not responding in real time, but it's getting there. Here you go, two sample t-test, number 4, guys. Okay, see, x1 bar. What do I have for x1 bar? 0.57. Watch. So we're doing section 8.2 if you're wondering. 0.79. N1 is 21. That's why I wanted other students to be here today, because I'm reviewing chapters that we've done a while ago. X2 bar is 0.39. S2 is 1.03. There's a lot of variation here. N2 is 21 as well. And since you guys told me the alternative is greater than, I have to select the greater than, of course. And then pooled. He says, do not assume that population standard deviation are equal. So pooled is no. And here you go. So T is 0.63. Two decimal places, so it will be 0.64. You put it here, right here where the mouse is pointing to. And then the p-value, guys, will be 0.26. How many decimals? 3 decimal places, 0.264. And then the conclusion will be, fail to reject the null hypothesis. There is not enough evidence to support the claim that those who treated with magnums had a greater mean reduction in pain than those given placebo treatment. Is it valid to argue that magnets might appear to be effective if the sample size are larger? So let's see what we have selections here. Is treated with magnet is yeah. If the sample sizes were larger, it might appear that they are more effective. But look at the sample size, guys. It was only at 21. That is a small sample size to compare to. And the other issue, look at the variation. The variation are very, very large here. Look, the standard deviation, the variation is even bigger than the mean itself. That's another factor that affected the results. Okay, number 4. Okay, let me clear here. Okay. A researcher claims that the stomach of blue crabs from location A contain more fish than the stomach of blue crabs from location B. Location A is number 1 and location B is number 2. Can you guys tell me which one is the null and the alternative hypothesis? Select between A, B, C, and D. Look, follow the signs, guys. Don't follow mu1 minus mu2. It's the same thing as mu1 less than mu2 or mu1 greater than mu2. So which one do you think will be the null and the alternative? We want to check if crabs that we get from location A contain more fish than in the stomach than crabs we get from location B. I agree. It is B. Greater than, more, and then less than or equal to. That's the only combination that we need. This combination, guys, is the same thing as saying mu1 is bigger than mu2 and mu1 is less than or equal to mu2. So it's exactly the same thing. Okay, the stomach contents of a sample of 13 blue crabs from location A contain a mean of 192 milligrams of fish and a standard deviation of 39 milligram. It's talking about a sample. The stomach contents of a sample of 9 blue crabs from location B contains a mean of 130 milligrams and a standard deviation. At alpha equals 10%, can you support the researcher claim? Assume that population variances are equal. You see, guys, he's giving you a hint. This is a 2-sample t-test. When he says assume population variances are equal. Let me see on the screen, come back. So let me just underline this. And that means, guys, that pooled is yes, pooled is no. What did he say? Equal? Equal means pooled is yes, sorry. So pooled is yes. Then you know you have no choice but to use the two sample t-test, because pooled is located only in the two sample t-test. All right. So if I just bring this whiteboard here, no. Just put the data that we have in there. So let me show you guys. So we have location A, and then we have location B. We have X1 bar, which is, let me show you. Okay. Mean of 192 and a standard deviation of 39. And how many blue crabs from location A? We have 13, N1 is 13. Let's go to location B now. Contains a sample of 9, so N2 is 9. X2 bar is 183. And S2 is 45. Can you guys see the new screen, what I'm writing on right now? You just let me know, please. I don't want to write to myself here. Okay, good. Thank you. Yeah, this is Microsoft Whiteboard. Is a lot better than using the annotators in Zoom. It hasn't been working well for me. So we're going to be using a two sample t-test, guys. And since the population variances are equal for pooled, we're going to put a yes. That's all you need to know. So let's bring the calculator up and perform the test. So let me just do that. I'll bring the calculator up. There you go. And I clear this. Stat, tests, two sample t-test, enter. All right, guys, X1 bar. We agree it's 192. Standard deviation was 39. That's what I wrote on the whiteboard. Sample size was 13. X2 bar, we put 183. Then we put 45 for standard deviation. Then the sample size was 9. Oops, sorry. And then mu1 is greater than mu2. So you have to scroll here, guys, and select enter. And for pooled, we're going to select yes. It makes a big difference in the answer. Oops, didn't select yes. Enter. Now it is selected. So just be very careful. Look it up before you run the test, or you hit calculate just to make sure that you didn't miss anything. And I can hit calculate here, guys, if you wish. Okay, T is 0.5. So you put it right here. P-value is 0.31. How many decimals? 4 decimal places. It will be 0.3112, which is bigger than alpha. So you fail to reject HO. and there is not enough evidence at the 10% level of significance to support the claim. Fail means there is not, so just use there is not here. Okay, that's a complete, let me show you a completed problem right here. Yeah. But you're wondering about the answers are different from what I came up with. Remember, the system will create a different problem right away here. So it's 16 blue crabs. I didn't have 16 and there, but fail to reject HO, there is not enough evidence to support the claim. Okay, one more before I go to the project. Okay. This is section 8.3. Let me just skip this and I'll come back to it later on Monday. I want to do a quick one. That's 8.3 as well. 8.4. Yeah, let's do this. That would be fast. In a study, okay, of binge drinking, the percent who say that they had engaged in unplanned activities because of drinking alcohol was 26% in 1993. N was 158. And 29% in 2005, N was 400. So the sample size was 482. Is this change statistically significant at the 0.05 significance level? Complete parts A to D. So you want to check if there is a difference in those percentages. So which one do you think, guys, would be the null and the alternative hypothesis? Any answers here? So it was 26%. Now it is 20. He's not asking us if it is a bigger change, a higher change, or a smaller change. He's asking if there is a change.
D.
Let me see. It is the D. And if you put a B, you just, yeah, D, because you got confused. But remember, HO cannot have not equal signs. So he mixed them up just to confuse you here. Be very careful. It is indeed D. Okay. And then, okay, let me show you. So guys, there shouldn't be any confusion about the test. It's a proportion. It can't be a T test or Z test. It's a proportion test, and it's a 2 proportion Z test. And let me show you how to perform this test, guys. So let me bring the calculator up. Okay, I'm gonna close this. Bring the calculator up, clear, stat, tests. 2 prop Z test, and watch. Okay. We need how many responded in the first survey? We say it was 26% out of 158, but he didn't give us the actual number. So we need the actual number. So look what you do, guys. You take the 26% and change it to a decimal and multiply by 1, whatever the number is, 158. So 0.26 times 158. Okay, but I got a decimal. You're not allowed to have an X value. X is a number of successes. It can't be a decimal. So just make it a whole number, 41 out of 158. X2. X2, he says 29% out of 482. So look what you do, guys. You just do 0.29 times 482, and then you put 482 right here. And you need to round the other one decimal. Round it to the nearest whole number, so that will be 140. Let me see what we have in the chat. No, not round up, just round. Okay, so P1 is different from P2, guys. Enter and hit calculate. And you're on your way to get the answer. So Z is negative 0.75. Hundredth means 2 decimal places. P-value, guys, how many decimals he wants? Hundredth, 2 decimals, 0.45. Well, 0.45 definitely is bigger than alpha. So what is it going to be? We don't have sufficient evidence. So we don't have sufficient evidence to reject the null hypothesis. So we can't reject the null hypothesis. That means we cannot support the claim. So we are unable. He changed the language here. Not, instead of not, he put unable to show that there is a difference in the proportion. So this is the review, guys, of section 8.1, 8.2, and 8.4. On Monday, I'm going to review 8.3, and I'm going to review chapter 9 and chapter 10 again. So and I can assure you guys, your test is just going to reflect very much on what you're seeing right now. So do a good job in preparing, just this study guide, and you should not be surprised, just with the questions. Okay, so